So Ryan Murphy uses design and system thinking to search for strategic opportunities for change. His emerging research practice examines how data and design may help us to understand complexity, how we may use models of complex problems to design effective strategies in weekend problem solving, and how change makers develop the use of skills necessary to engage in all the above. Ryan is currently a PhD candidate in management information systems at Memorial University of Newfoundland. His supervisor is Dr. Jeffrey Parsons. He holds a Master's of Design in Strategic Foresight and Innovation from OCAD University and a Bachelor's of Science in Psychology and Computer Science, software engineers from Memorial University. So welcome.
Thank you. So the talk is titled Enabling Data Serendipity, the Role of Conceptual Modeling in Collecting and Analyzing Serendipitous Data. And because we know how Zoom conferences work, if you want to check your email or something and tune out at any point, I'm just going to spoil the whole talk right away. It really boils down to three, I think, key points. So I'm just going to highlight them, and then, yeah, if you need to go, get a coffee or whatever, I think you'll be able to come back and still have a fulsome conversation. But I'm still going to I'm going to go into more detail throughout the rest of the talk, obviously. So 3 key takeaways. The first is that our conceptual models, how we exactly represent the data or the world in our data, constrain the content and form of data we capture and how it may be used. So that's the first takeaway, is like we constrain the potential for serendipity with our conceptual models. And I'll talk about what conceptual models are. And that constraint happens because if we don't capture or recognize surprising data, unanticipated data, because we don't have any room for it in our conceptual model, then we can't be surprised by it because the data never shows up. And we might be able to solve that problem, or at least minimize it, by designing for serendipity. And so I'm going to talk about some of the ideas that I've seen and that we've had about designing for serendipity. And that's the whole talk. But as I dive in deeper, I just want to disclaim a few key things. The first is that this work is based on data crowdsourcing research. Data crowdsourcing is the use of the crowd to collect or analyze large amounts of data. And so I do think that this is generalizable to other domains of big data, and perhaps we can have a conversation about what that looks like. But this is anchored in that data crowdsourcing domain, so that's just going to tune or set a sort of tone to everything else. The second is that at some point throughout the talk, you might hear my own little engine of serendipity in the background. I have a 10-week-old at home, my first daughter, and so she is, serendipitously smacking herself in the head and realizing that she has hands and so on. And sometimes she might get a little upset and cry out. So if you hear wailing, that's probably what it is she's discovered something new accidentally, and hopefully she'll keep doing that. And then the third is that you all are intimidatingly philosophers of science, or at least not all of you, but many of the talks that I've seen and the abstracts that I've read. I don't consider myself a philosopher of science, and I just wanted to kind of anchor that. I'm very curious about your perspectives on the talk, but it might seem a little different from that philosophy anchored point of view. So if you'll walk with me for a second, I wanted to start out with a bit of an exercise. And this is based on a true story, a couple of true stories, just sort of mixed together. And I'm wondering if a couple of you are brave enough to sort of leave your mics hot for a second. I might ask for you to shout some things out as I walk through this story. So I want you to imagine that you have, you've just been discovered, serendipitously, this exciting new platform. It's a data crowdsourcing platform called Eco Observer. And the idea of Eco Observer is for you to, enjoy wildlife. It's a pandemic. You can't do much, but you can walk in the woods. And so as you are out enjoying wildlife, Eco Observer encourages you to take a photo of that stuff and upload or describe what it is. Okay, so that's the platform. You're super excited about it. And so you are adventuring, not necessarily that exciting of a place. You're sitting on a bench somewhere eating some fast food, and a bird flies down and lands next to you. But still, hey, it's wildlife, it counts. You're excited about Eco Observer. And so you capture a photo of that bird and you upload it to the site, and now you're going to describe what it is. So What is this bird that you've seen? Which of these three options is it? Anybody?
I can't really read it.
Oh, it's too small. Oh,
Yeah,
no.
too small.
Okay.
Yeah, and I'm a bit blind.
No, that's okay. That's a good point. So what if I switch to full? Is that a bit more legible?
Yes,
Almost.
Laura's Delaware person. I have no idea.
No idea? Yeah. Okay. So that's what I expected, right? So you are you're experimenting with this platform, and you go in here and you take a photo of your bird, and it's a beautiful bird it's a beautiful photo of like a seagull trying to get some French fries or whatever from you. And you want to say what it is, but this is the list that you're presented. So what are you going to do but get angry? And then you're probably going to leave EcoObserver and go figure out what new misinformation is being spread on Facebook or whatever. So you give up on EcoObserver for a little while, but then, there's a bulletin. They tell you that they've upgraded their systems. You go find your photo again, and then which of these are you going to choose? The options are, Gull, absolutely, you got it. So this is more delightful, right? You are able to contribute in the way that you want, and so you're excited about EcoObserver again. So let's say you finish your food and you take a walk, and you're walking through the woods somewhere far away, and you hear a cough in the woods, which is kind of weird. And then all of a sudden, lumbering out of the woods comes this big animal. Anybody know what this thing is? You take a photo of it. Yeah, it's number 2. It's moose. So you've captured a moose and you've uploaded it, and you've said, "Hey, I've caught a photo of a coughing moose." And then you are leaving the woods, and then just before you're finished, this annoying bug lands on you, and so you're interested, or you're ready to kill it. Suddenly you realize it looks a little bit different, right? So you decide to capture a photo of it, and then you kill it because you don't want it to bite you. But which of these is it? It's the mosquito. So you upload this photo of a mosquito that you've never seen before, a kind of mosquito that you've never seen before. And now EcoObserver has these 3 observations. Congratulations, good work. You've participated in data crowdsourcing. You're a citizen scientist now, and the world has benefited from your involvement. But how much, we'll see. So I'm going to return to that in a bit. But first, we're going to walk through some fundamentals of the ideas that I'm presenting in this talk. The first fundamental is that our systems of data, the things that we capture, whoops, I'm standing in front of this little abstract diagram. The things that we capture represent the real world, but they're not the real world, right? When we take a photo of that moose and we upload it to the system, we're not actually putting a moose in the computer. It's a representation of that moose in the real world. And so, to make this data useful, by necessity, we have to represent only the aspects of the world that are relevant to whatever the project we're working on might be. And this is a kind of simplification. It's a process called conceptual modeling. So basically, we develop a conceptual model, and I'll talk a little bit more about how, and then that conceptual model constrains what we're able to represent with data about the real world. So every data project uses conceptual model, but most or some may be implicit. It's not necessarily always a conscious exercise to try and develop an explicit conceptual model and make sure that you've captured everything. So when you go to, say, create a survey and list all the questions in the survey, you're creating an implicit conceptual model of the kinds of data you want to represent in the eventual research you're doing. But if you don't step back and sort of do a complicated modeling process that isn't necessarily an explicit structure, we can talk a bit later if you want about what exactly it might look like to do that differently. But this process is typically done through what we call requirements analysis. So an analyst, whoever's building the system, will examine the domain, maybe interview some stakeholders, or at least think about what the stakeholders might value. And then they design the system and the conceptual model to represent the most relevant aspects of that domain. But obviously, this preordains what can happen in the system, right? If you don't have a slot for mosquito, then somebody takes a photo of the mosquito, it becomes more ambiguous kinds of data in the system. And this presents an immediate constraint. By deciding what we expect to find in advance, we limit our ability to observe what we didn't expect. So we know one of the values, or one of the exciting things about big data, is that you can get a lot of variety in big data. It's one of the 4 V's from Stonebraker's original conception of it. That means we can capture more diverse data than ever before, but if we are constraining what we're going to collect by what we expect, then are we taking full advantage of that variety? And that is the question. So in big data, in the industry at least, there's this process called CRISP-DM, the cross-industry standard process for data mining. And it sort of defines the general approach for how data mining and how big data might be processed, right? So you've got this cycle between business understanding and data understanding, where you first try to understand the domain, as I talked about before. Then you understand what your data looks like. You might go back and forth a little bit. Then you prepare it. You send it over to some modeling process, some not conceptual modeling process, but machine learning process. You evaluate whether or not that was useful. Then you go back to business understanding and you see if it was what you wanted. But what's missing from this diagram? And that's exactly how you design that conceptual model and collect data ultimately for the project. Arguably, you could say that's part of the data understanding block, but I think the point of this talk is saying that conceptual modeling as a key part of this process is being underemphasized at the very least, right? And so we have three different approaches here. In an old non-big data process, we might model first, like I said before, like I talked about with the requirements gathering. You might sit down, design this UML diagram of a complicated set of data that you want to collect, and then build the database for that. So that's called a model first, data after paradigm. Then in big data projects, what we just saw is you might have a data first, model never, conceptual model never paradigm, where you let the machine do the modeling, but you're not worried about what the semantics of the machine you're not worried about the semantics of the machine understands. Or my supervisor suggests you could have a data first, model after. And that is where you work within that CRISP-DM process and you add in conceptual models to different parts of the process in order to inject some domain understanding, some semantic ontological understanding of what exactly the data is and what it means. And what I'm suggesting here is that this needs to be an iterative thing in order to build on and expand the data we're collecting, in order to see what we're collecting that might be unexpected, and then build that back into our conceptual models, and then use that to inform the data processes that or the decisions we're making based on the data. So that looks maybe a little bit more like this. At the start, you really need to start by defining your conceptual model, and I'm going to talk a little bit more in a bit about how to do that with serendipity in mind. You then collect data, and you use that to drive data understanding. So I would append this sort of piece to that CRISP-DM process in order to design for serendipity. So this is the process bit. But how do we model for serendipity? What exactly do we do on that conceptual modeling step in order to try and capture the unexpected? And so now we're going to return to the exercise that we had, that we participated in earlier. Where do we lose the unexpected? Well, we saw three things. First, you didn't know exactly what kind of bird this was when we used the Latin for the species representations. So if you build a platform for ecologists, right, who are experts at what exactly the wildlife is, they might see a seagull and say the Latin name for it. But if you're an average bear like me, you might not have any idea what that is. And then you're discouraging participation, right? So what you're actually losing is unexpected participants, unexpected contributors to your data. So that's one area. The second is that you might remember in my story, the moose coughed before it came out of the woods, right? And so what you're missing here is you're classifying, or sorry, you're not appreciating the unique attributes of this instance of data when you upload a photo of a moose and just say it's a moose, right? It had some interesting attributes. It was coughing. This could have been the first ever case of moose flu, right? That you want to make sure that you're appreciating and capturing and tracking. But if you don't give your participants, your contributors, any ability to add those kinds of attributes to the data that they've uploaded, if they've contributed, then you're going to lose that. And the interesting thing about that moose, the fact that it was coughing, gets lost. And then the third thing was that you might have noticed that this mosquito that you've never seen before had a little pathogen inside it too. And that the idea here is that if you have a classification of a mosquito, but it doesn't include the kinds of mosquito that have never been seen in an area before, then you lose it. Sorry, I'll clarify that. So you have a box for mosquito, but it's not a new kind of mosquito. It's just like a conventional kind of mosquito. So you're just modeling the kinds of mosquitoes that you expected. So what actually gets uploaded to this database is an incorrect idea of what this mosquito is. It's actually a rare new kind of mosquito. And in this case, it carries the West Nile virus, and you've never seen a mosquito in the region that carries the West Nile virus before. And so these are actually three stories that they're hypothetical in this case, but they're based on true stories of crowdsourcing platforms where, yes, we discouraged people from participating because we expected them to have an expertise or a skill set that they didn't have. The second is some exploration we're doing around data granularity and whether or not we're allowing people to upload attributes of the things that they're observing. And so in the real world case, you had people upload photos of wildlife that they saw, and they would add that the wildlife was beautiful or healthy. But because the system didn't necessarily, or well, in our experiment, it was capturing these things, but most data platforms that are capturing generic observations and not capturing those details are losing those details. So if you wanted to query, you know, what is the most beautiful wildlife in the region and get a crowd, get an idea of what the crowd thinks is the most beautiful wildlife, but you're not collecting those attributes of beauty, then you're never going to know. And then the last story, there was a case of discovering this rare species of mosquito in a region that carried the West Nile virus and wasn't known to be in the region at all. So suddenly this is like a really important observation for, say, tracking the health system, right? Realizing that suddenly the West Nile virus might be spread in this area that hadn't had it before. So what does this mean for conceptual modeling and serendipity in big data? It points to those three reasons that I mentioned before. The first is that you can lose unexpected contributors if you don't design for them. And so you need to make sure that your conceptual models match user expectations or abilities, because otherwise you're going to cause confusion and frustration, and they're going to leave, and you're going to lose out on what they could contribute. The second is a loss of detail. Over classifying, only capturing higher level abstractions of whatever it is that people are submitting, it tyrannizes their individuality. It loses those attributes that might be really important, but you don't know they're important until you see them and have that unexpected bit of insight. And then the third is a loss of diversity of contributions. If you don't include ways for people to contribute unexpected classes, those unexpected abstractions, then you're going to lose contributions in general. So in order to kind of try to wrap this up, I wanted to propose thinking about data serendipity as a quality of data. We usually talk about the value of data as being things like complete, and that means that you captured everything about a phenomena that you could. Sufficient, as in it's at a sufficient detail to understand what it represents. Meaningful, it's actually corresponding with something real. And then correct, so it's actually the right state of things. But we can actually also think about the quality of our conceptual models. And so some of the work that I've been doing looks at what kinds of attributes conceptual models might have in order to contribute to good data quality, and in order to contribute to serendipity overall. And so in this case, I'm just proposing, this is a slide that is, I think, up for debate. I'm very curious about what you think a good conceptual model looks like in order to encourage serendipity. But a few things that we have seen that I've thought of is your conceptual model needs to include space for diversity. It needs to be granular enough that you can capture those interesting attributes or properties of the phenomena that you're observing, and so on. So I don't know what the real answers are here. The research that I've done has kind of borne out this idea of granularity being valuable, but I'm curious about debates on the other kinds of attributes that you would add in there for conceptual model quality. And so what we have, and this is kind of drawing to a close, I hope I'm relatively on time. These are a few tips on how we might design effective conceptual models to encourage or enable serendipity. So the first is that process piece, right? Data first, model after, and then do that iteratively. Make sure that you are taking in data, looking at what might be surprising or unexpected, and then adapting the platform or the project in order to be able to capture more of that unexpectedness. The second is making sure that everybody who can contribute, making sure that you're not blocking participation somehow or losing contributors, losing the kinds of people who might participate. The third is to make sure that you can collect enough detail in contributions. And so here we argue that you should design for granularity. You should collect a bunch of attributes and then use those attributes to generate what exactly the classes might be, rather than doing it from the top down, capturing moose and then not actually getting any of the attributes that made the moose interesting. And then the last one here is making sure that you capture a diversity of contributions by including perhaps a smart other. And I'm sort of spitballing here. We've all seen the other box, and that is really where the serendipity goes, right? You know, is you have a survey question and there's sort of a 5 options on a bullet list, and the 5th option is other. But that box, I don't know if maybe I'm the only one who's gone about it this way in the sort of feedback questions that I've gotten in projects, but or that I've surveyed in projects. But if you collect that other data, it often becomes a kind of mess, right? You look at it maybe very briefly, but it's the bullet points that are easy to correlate that you're really interested in. So are there ways of redesigning the other box in order to be able to capture that and build patterns that might be unexpected? I'm not going to talk through this in detail. I was thinking about it, but we created a contribution-centered typology of crowdsourcing, data crowdsourcing projects, and I think it does apply a little bit here. And I can return to this if you want, but the idea is that there are these 5 dimensions of crowdsourcing projects, of data crowdsourcing projects. And those 5 dimensions will change exactly how you can design for serendipity. And so, for example, some projects might have a really well-defined definition of a successful contribution. And that might be necessary sometimes if you're, say, working on a short timeline or if you have a limited budget. But in general, in order to design for serendipity, you might want to allow participants to contribute in more open-ended ways. So not using that drop-down list, but instead having a text box with an autocomplete that enables people to contribute what might not be your preordained idea of what a successful contribution is. And then the last point I wanted to make is to talk a little bit about ontology. Conventionally, a lot of the information systems, a lot of the data projects that we are used to kind of have this Bungay Wand Weber approach to understanding the world. And so that's the idea that the world is made up of things. But recently, one of my co-supervisors has been doing some work on the later work of Mario Bungay. And even though Bungay's work originally started by thinking about the world as made up of things, he later started to think about the world as made up of systems. So a lot of information systems and conceptual modeling projects are based on this old idea that we're looking at things only, but Bungay actually adapted that, and then information systems researchers never went back and changed their understanding of the world from Bungay's new understanding of the world. And so this is probably a way too big of a point for a sort of near final slide. But if we recognize that the world's made up of systems and that things are systems, then we can actually try to model and collect data on what these systems are made up of, their composition, their environment, how they relate to other parts of the context, the structure, how the parts of the systems relate to one another, and the mechanism, what exactly it does. And so the idea here is to be a little bit more granular, I suppose, in breaking down what the things we're modeling are, and using these 4 variables in order to make sure that we capture them as systemically as possible. And then the last point from this new idea of the general systemist ontology is that when you're capturing these data contributions, you don't only want to capture the thing itself. And that's, again, coming from that old way of thinking of the world made up of things, because an observation is not just the thing itself. An observation is who observed it, what they used to observe it, and under which conditions they observed it. And if we're able to capture those things, you might be able to, or if we work to modeling with those things in mind, you might actually be encouraging people to say, why did you take a photo of that moose? And then capturing details like, well, it was coughing. That's why it was interesting. So I'm kind of coming to a close here. Yeah, so this is my final slide. And I wanted to close with this idea that datafication is a really important filter because it abstracts the observer from the observation. And that means that you have less of an ability to recognize what might be unexpected, right? If you are filtered, if the things that you're trying to work with are filtered through this conceptual model and through these data platforms, then you can't observe directly the things that might be unexpected. But there might be ways of designing conceptual models with serendipity in mind, opening up the possibility for the unexpected and for new insights. The real question is how, and that is it for me.